Good afternoon, sir.
Okay, good afternoon. Okay, good afternoon all.
Good afternoon, sir. Good
Okay,
afternoon.
so today we are going to start new topic, that is vibration of air column in a pipe which is closed at one end. Okay, so what does that mean? That means first you have to take one pipe which is closed at one end. So let's
And
start.
open in one end.
So let
Good afternoon, sir.
okay, so let this pipe be closed at one end. तो ये साइड में, यहाँ पे इस साइड में closed है. Okay, now we want to find the vibration of which column? Air column. That means in this pipe we have air molecules like this. Okay, so we have to set these air molecules into vibration. That means they have to perform like a wave. जो भी superposition of wave होता है ना, like this. So these air columns will have to perform a wave like structure. That means we are going to pass a wave from this air column. For doing that, we have to use a tuning fork. Okay, tuning fork is an iron rod in this shape. Okay, this is called tuning fork. जब इसको हम लोग किसी इसके ऊपर इस तरह से मारेंगे तो what happens, that this creates vibrations. Okay, because of the vibration of this tuning fork, the air column in this pipe will also start vibrating. That means यहाँ पे stationary wave generate होगा इस pipe के अंदर. Okay, so suppose the length of this pipe is small l. Just a second. Okay, here. Okay, so let the length of this pipe be small l. Now when we set up this air column into vibration, the smallest सबसे छोटा वेव कौन सा हो सकता है? स्टेशनरी वेव, जिसके अंदर एक नोड हो और एक एंटी नोड हो. That means it must have one node and one anti node. Okay, that would be the smallest or you can say simplest part of this wave, जिसके अंदर we have to put one node and one anti node. Okay, now when you set up this air column into vibration, तो nodes कहाँ पे generate होगा और anti node कहाँ पे generate होगा, वो हमें देखना है. First see here, for generating an anti node, you need a larger space for the particles to vibrate. ठीक है, अगर हमें एंटी नोड जनरेट करना है तो उसके लिए ज्यादा जगह की जरूरत पड़ेगी, क्योंकि पार्टिकल नीड फ्रीडम फॉर देयर ऑसिलेशन. ओके, एंड फॉर जनरेटिंग नोड you don't need any space because particle कैसे होते हैं, particle is at rest. Okay, so at the close end, that means here the particles will have very less space for their vibration. That means always this node will be created at the one end, at the close end, and at open end, see here, open end के just बाहर, मतलब ये open end है, इसके just बाहर यहाँ पे जो particles हैं here, they have a very large freedom. उनके बहुत ज्यादा freedom है, वो space में कहीं भी vibrate कर सकते हैं. Okay, so this antinode will be formed just outside this pipe. इस pipe के just outside में यहाँ पे हमारा जो antinode होगा वो form होगा. तो देखते हैं कि basically the simplest wave which we can form would be like this. Okay, so this is the simplest wave we can form, in which we have one node which is at the closed end and one antinode which is just outside this pipe over here. So this is the antinode. Okay. In the last lecture, we talked about end correction. End correction का meaning क्या है? पाइप के जस्ट जो लेंथ बाहर होता है जहां पे हमारा एंटी नोड बनता है, this length is called end correction and it is denoted by small e. Okay, so the total length of this air column will be equal to small l plus e. So we can write, one second. So we can start our topic. The first mode of vibration in a pipe closed at one end will have one node and one antinode. What does this mean? Okay, so इसका जो first mode of vibration है उसमें at least we will have one node and we will have one antinode. That is called fundamental vibration. क्योंकि ये सबसे simplest है, इससे ज्यादा simple कुछ भी नहीं हो सकता. Okay, so therefore the length of the air column, the length of air column will be, now we have to find the length of the air column. Okay. See here in this diagram, if you see in this diagram we have one node and we have one antinode, and this is the length of that air column. So we all know that, मैंने previous lectures में बताया है, the distance between one node and one antinode is always lambda divided by
4.
4. So length of this air column would be lambda divided by 4. Therefore, from here we can find the value of lambda as 4L. Okay. Now, if small n is the fundamental frequency, small n is natural or fundamental frequency of this air column, fundamental frequency. Okay, then the velocity of this wave is always given by, ठीक है, वेलोसिटी का जो फॉर्मूला होता है वेव का, दैट इज गिवन बाय फ्रीक्वेंसी मल्टीप्लाइड बाय वेवलेंथ. Always remember this formula. The velocity of wave is given by frequency multiplied by wavelength. Okay, so from here we can find that n is given by v upon lambda. You have to just rearrange this. Okay, lambda udhar jayega, divide mein aayega. Now we have to substitute this value of lambda in this equation. So we will find that n equal to v upon, instead of writing lambda, you have to substitute 4L. Okay, now v divided by 4. This L, this is the length of the air column, which is equal to the length of pipe plus length of this end correction. So here for L we can substitute small l plus e. This is the length of the pipe and this is the length of the end correction. End correction means जहां पे पाइप के ऊपर जितने डिस्टेंस पे हमारा एंटी नोड बनता है, that length is called. Okay, so let this be question number 1. We can write here, this is called the fundamental frequency. और इसका दूसरा नाम क्या है? फर्स्ट हार्मोनिक. First harmonic. So write it down. Take this screenshot till here. Okay, have you completed?
Yes, sir.
Now we will move to the higher state of this air column. In first mode we seen one node and one antinode. When we move to higher states, we will see two nodes, how two nodes and two antinodes are formed in this air column. So for that I have to draw a different diagram. From here you just remember this equation. Okay, ये equation आगे next के लिए use होगा. So you just remember this equation, n equal to v divided by 4l plus e. Okay. So now we will take one pipe again, which is closed at one end. Now we have to generate two nodes. That means one over here, the other would be somewhere here, and two antinodes. Okay, so the wave will form a structure like this. Correct? Here we have two antinodes. One is here and the other one is this, and two nodes. So these are nodes. Here also node and two antinodes. So you can say this is the first higher level air column vibration. For doing this, you have to set this tuning fork in such a manner it produces only two nodes and two antinodes. तो basically ये जो हम लोग tuning fork use कर रहे हैं, इसके ऊपर डिपेंड करता है इसके अंदर कितने कॉलम्स बनेंगे, कितने नोड एंड कितने एंटी नोड बनेंगे. So these tuning forks come of different frequencies. इनका जितना frequency होगा उसके हिसाब से ही यहाँ पे error column generate होता है. Now we want to find the length of this error column. इसका length कितना होगा? Okay. So see here. This is antinode. This is node. The distance from here to here is lambda by 4. Next, again antinode to node. The distance from here to here is lambda by 4. Again, here node to antinode. The distance from here is to here is lambda by 4. So lambda by 4, lambda by 4, lambda by 4. We have 3 lambda by 4. This is the length of this error column. Okay. So let's write if the frequency of this tuning fork is n. If n1 is frequency and lambda 1 is wavelength, then तो ये साइड में लिखता हूँ L equal to 3 lambda by 4. Then the length of air column is okay L equal to 3 lambda by 4, 3 lambda 1 by 4, because we have selected wavelength as lambda 1. Okay, so here frequency and wavelength both will be different for generating this two node anti-node system. Okay, so from here we can find the value of lambda 1 as 4L divided by 3. Okay, now again we have to apply the formula for velocity. So we can write but V equal to N1 into lambda 1. Correct? So from here we can write the formula for N1 as V divided by lambda 1. Now you have to substitute this value in this equation. So you will get N1 equal to V divided by. So when you substitute this 4 upon 3L over here, then this 3 comes out on upper side and this 4L will be in the downward. Now if you substitute the value of L as L plus E, you will find 3V divided by 4 L plus E. This is equation number 2. So if you compare equation number 1 and equation number 2, you will find that this one N1 is 3 times this N. यहाँ पे देखो ध्यान से, इसको देखोगे और इसको कंपेयर करोगे तो इसमें ये 3 वैल्यू ज्यादा है. ठीक है, that means therefore N1 is 3 times the natural frequency. N1 is 3 times its natural
frequency.
Okay. So that means this N1 is, therefore N1 is which harmonic? Third harmonic. Okay. और ये फर्स्ट हमारा हायर फ्रीक्वेंसी है. फंडामेंटल फ्रीक्वेंसी के बाद दिस इज द फर्स्ट हायर लेवल फ्रीक्वेंसी. So this would be called as first overtone. So N1 is third harmonic and first overtone.
स्क्रीन नहीं दिख रहा सर। सर स्क्रीन नहीं दिख रही।
हेलो सर, आपकी स्क्रीन नहीं दिख रही है।
स्क्रीन नहीं दिख रही है सर, लीव हो गए।
सर लेफ्ट
नहीं हुए, होस्ट अभी भी है।
वो एक्चुअली नेटवर्क का इश्यू था। ठीक है, तो स्क्रीनशॉट लिया सबने?
Yes, sir.
Now we will see how we can generate 3 nodes and 3 antinodes. Okay, so this was our third harmonic and first overtone. Third क्यों? क्योंकि यहाँ 3n आया था. It was third multiple of natural frequency, that is called third harmonic and first overtone. क्योंकि natural frequency के बाद first वो higher level का frequency था, that is called first overtone. Okay, तो अगर तुम्हें उसका overtone और harmonic का definition मालूम है, so you will know how I have written third harmonic and first overtone. Now we will see one more higher level energy vibration state, in which we will have 3 nodes, 1, 2 and 3, and 3 antinodes. So here we have 1, 2, 3 nodes and 1, 2, 3 antinodes. Okay, so what would be the length? Yes, count and tell me what would be the length of this air column. How to count? यहाँ से half तक इतना कितना है? Is lambda by 4. Then from here to here it is lambda by 4. So 2 lambda by 4 हो गया. Now from here to here lambda by 4. So 3 lambda by 4. From here to here lambda by 4. 4 lambda by 4. And again from here to here lambda by 4. So basically we have 5 lambda by 4. So this is the length of the air column. Okay. You know how to count this? ये तो समझा ना?
यस सर।
Into the frequency and lambda to this wavelength. Again वही प्रोसेस रिपीट करना है. यहाँ पे n2 फ्रीक्वेंसी लिया, lambda 2 is our wavelength, so we can write यहाँ पे we have to write lambda 2. The length of air column will be equal to L equal to pi lambda 2 divided by 4. From here you have to find the value of lambda. So by rearranging you can write lambda equal to 4L divided by 5. Now again we have to write the equation of velocity. So but V equal to n2 lambda 2. Then by using this equation you have to write the equation for frequency, which would be equal to n2 equal to V upon lambda 2. Now you have to substitute the value of lambda 2 in this equation. So you will find n2 equal to 5. ये 5 ऊपर चले जाएगा, 5V divided by 4L. Okay. Now if you substitute the value of L in this equation, it will become 5V divided by 4 into L plus E. So if you compare this with the natural frequency, you will find that n2 is 5 times the natural frequency. How many times? 5 times. Therefore This is fifth harmonic and which overtone? Second overtone. Okay, so this is fifth harmonic and second overtone. Is it clear?
सर बोर्ड में दिख रहा है बाजू का.
Okay, थोड़ा
दिख
इधर,
रहा है दिख रहा है सर.
वो थोड़ा इधर का साइड नहीं दिख रहा होगा.
यस
सर थोड़ा ब्लर दिख रहा है.
यस सर.
ब्लर दिख रहा है. ओके रुको मैं
नो नो
वो कभी नेटवर्क की वजह से हो जाता होगा ब्लर.
वो एक सेकंड में होता है फिर गायब हो जाता है, क्लियर हो जाता है.
तो सेकंड ओवरटोन. Okay, take this screenshot till this, then we will write the conclusion for this equation. अभी इसका हम
Done,
लोग
sir.
conclusion लिखें.
डन सर.
So we can write in general. Okay, अभी हमने कौन सा हार्मोनिक फाइंड आउट किया? कौन सा ओवरटोन फाइंड आउट किया? सेकंड ओवरटोन, राइट? एंड फिफ्थ हार्मोनिक. सेकंड ओवरटोन,
हार्मोनिक सेकंड ओवरटोन, फिफ्थ हार्मोनिक.
so in general we can write general for fifth overtone, the formula would be like NP equal to 2P plus 1 into N. So this would be the general formula for finding the overtones. ठीक है, तो इसमें कोई भी वैल्यू पी की सब्स्टिट्यूट करेंगे, जैसे 6th 7th 8th 10th जो भी फाइंड आउट करना है, वी कैन फाइंड आउट द वैल्यू. ओके, so suppose we want to find the third overtone, तो यहाँ पे p की वैल्यू 3 सब्स्टिट्यूट करेंगे. 3 into 2 would be equal to 3 2 6, 6 plus 1 7. तो नेक्स्ट होगा
7.
आएगा. Okay, write it down, then we will see the condition of pipe open at both ends. अभी 10 मिनट टाइम है तो उसमें हो जाएगा. Do it fast. हो गया?
यस सर.
Yes, sir.
Now we will see the vibration of air column in a pipe open at both ends. Open at both ends. Okay. So basically, let's take one pipe which is open at both ends. Okay. Now we want to find the simplest. इसके अंदर जो सबसे simple air column वो बना सकते हैं, वो कौन सा बना सकते हैं? First of all, see that जो दोनों ओपन साइड है, हमेशा ध्यान रखना, एट ओपन एंड्स वी कैन ओनली फॉर्म एंटी नोड्स. ओपन एंड पे हमेशा एंटी नोड ही बनता है. ओके, दैट मींस इन द मिडिल समवेयर वी विल हैव नोड. ओके, एंड टू एंड्स वी हैव टू फॉर्म एन एंटी नोड. So this would be the simplest form in this structure, where we will have two antinodes and one node in the middle of the pipe. Okay, that means here we have one E, here we have one E, So the answer would be, the length of this would be L equal to
lambda 1.
small l plus 2. वो हम लोग अभी देखेंगे. ये तो
सर वॉइस नहीं आ रही.
हाँ. Okay. So the length of this air column would be L plus
2e.
2e. Now we have to write it in the form of lambda also. Okay. So the distance from here to here is lambda by 4.
4.
The distance from here to here is lambda by 4. So it comes out to be 2 lambda by 4. But if you cut this, you will find that it is equal to lambda by 2. Okay. So here we can write बाकी सब वो हमने लास्ट में समझ लिया, तो डायरेक्ट मैं लेंथ से स्टार्ट करता हूँ. The length of air column is L equal to lambda by 2. So from here we can write lambda equal to 2L. Now we know the formula for velocity, and it is written as V equal to N into lambda. Okay. So from here you can find the value of N as V upon lambda. Okay. And we know that the value of lambda is 2 into L. So here we can replace lambda by 2L. Also we know that the length of this is L plus 2E.
L plus 2e.
So the equation would be V divided by 2 small l plus 2E. This is the equation of fundamental frequency. तो ये जो equation है ये कौन सा है? This is fundamental frequency. और फर्स्ट हार्मोनिक, इसका दूसरा नाम भी है फर्स्ट हार्मोनिक. So this is the fundamental frequency, also called as first harmonic. Okay, take this screenshot first, then we will see the other condition.
Done, sir.
Okay. Now we will see second condition, in which we will have 2 nodes and 3 antinodes. We have 2 nodes and 3 antinodes. Like this. So the length would be equal to, tell me what would be the length from here to here, lambda by 4, then again lambda by 4, again lambda by 4, here lambda by 4. So 1, 2, 3, 4, 4 lambda by 4, which gives you L equal to lambda. So in this air column, the length of this is equal to lambda 1. So again, starting from here, the length of the air column is L equal to lambda 1. Okay. Therefore, we have to write the equation of velocity, which is n1 into lambda 1. So from here we can find n1 equal to V upon lambda 1. Now if you substitute the value of lambda 1 over here, you will find n1 equal to V upon L, क्योंकि lambda 1 is equal to L. और L का जो फॉर्मूला है, that formula is L plus 2e. Okay. So if we compare n1 and n, दोनों में ध्यान से देखोगे तो क्या फर्क है? इसके डिवाइड में कितना है?
2 times से
Two
2 times
times.
That means n1 is equal to 2 times n. Correct? So this is first overtone and second harmonic. Okay. So this is first overtone and second harmonic. Okay. Similarly, we can go for higher level, that is for 3 nodes and 4 antinodes. Okay. So you will find there similarly, अभी उसको नहीं करता हूँ, ऐसे लिख दे रहा हूँ. Similarly, for n2 की जो वैल्यू आएगी वो आएगी 3n. Okay, 3n. That means second overtone and third harmonic. So in general we can write, therefore in general if for fifth overtone जो इक्वेशन बनेगा वो क्या होगा? np इक्वल टू p into n. This would be the formula, p into n. p plus 1. हाँ, क्योंकि 1 ऐड होते जाएगा ना हमेशा. ठीक, यहाँ पे 2 है तो यहाँ पे 3 है. दैट मीन्स अगर if this is 2 then it must be p plus 1. 2 plus 1 3. Okay, so this is the general equation for finding the overtones in a pipe which is closed at both ends. तो ये समझा? Is it understood?
Yes sir.
Okay. Okay,
Yes,
then we
sir.
finish the lecture for today.
Bye sir.
Bye.
Bye sir.
Bye.
Bye sir.